I made a summary of the whole process of calculating the complex power. Now, if we look at that example again, I just made a boo-boo there. I started off with a phase shift. So it's a phase shift of 2 degrees and a tap change of 3. And then a tap change of 2 and a phase shift of 3 degrees simultaneously. All right, so first of all, we calculate IA, which again is V1 minus V2 divided by the impedance between them. That gives us 10 angle minus 90, V1 minus 1 angle naught. V2 is always equal to 1 angle 0. And therefore, IB will be V1 minus V2 dash divided by JXB. That gives us V2 is now 1 angle minus 2 because it was plus 2 that side. So across the transformer, it becomes minus 2. So that gives us 10 angle minus 90 times V1 minus 1 angle minus 2. And then IB dash is IB times 1 angle 2. So IB dash becomes 10 angle minus 90, V1 minus 1 angle minus 2 times 1 angle 2. That gives us 10 minus 88 V1 minus 10 angle 90. And then as we've said before, I load is the sum of IA plus IB dash. Okay, so IB dash then is 10 angle minus 88 V1 minus 1090. So IA is 10 angle minus 90 V1 minus 10 angle minus 90 plus 10 angle minus 88 V1 minus 10 angle minus 90 is equal to I load, which is 1 divided by 0.4 plus J8. That gives us 1.18 angle 63.4. And then if we solve for V1, we get that V1 is equal to 1,05044 angle 0.366 degrees. Any questions up to now? Something that's not clear? Right. So IA is then 10 angle minus 90, 1,05044 angle 0.366 minus 1. That gives us 0.50864 minus 82.43. Oh no, here's your one. IB dash is 10 angle minus 88, like that. And that gives us
Mr. Luru,
0.658, yeah.
sir, can you go to the previous page? I want to move screenshot first.
Oh, come on, Zuma.
Please, man.
Eish. You must be wide awake. Not
Hey, something happened there. It was black. I don't know what happened.
you happened.
Down, the down part, yes. Thank you, I'm done.
Okay. And then I tried it both ways and I found that it works the same. So you don't have to worry, oh no, it's working out.
Yes, sir. Yeah, your example was wrong because I did it yesterday. Yes, I saw that it's working out.
Okay. So SA is V2 times IA is conjugate. That gives us 0.067 plus 0.504. SB is V2 times IB dash. That gives us 0,434 plus J.495. So you can see that the reactive power didn't change much, but the big change was between these two. All right, so if we have a tap change of +3, then again we have V1, IA1 is 10 minus 90, V1 minus 1, angle 0. IB dash is 10 minus 90 V1 over 1 angle 0 divided by 0.13. That gives us 10 angle minus 90 V1 minus 9.7087 angle minus 90. And then IB dash is IB divided by KT again, which gives us 0.9708 minus 90 V1 minus 0.94295 minus 90. And then if we solve for V1, we get 1.0367 angle 1,4 degrees. Is what? Right? And then we find that IA is 0.444 angle minus 55. And by B dash is IL minus IA. That gives us 0.682 angle minus 68.8. Calculate SA again. We get 0.254 plus 0.364. And SB is 0.247 plus 0.3636. There again, you can see the biggest change now happened in Q. And P remained basically the same. Right. Next one is where we use both. So a tap change of 3% and a phase shift of 2. So IA remains the same as 10
Your
minus.
screen is up. Sir.
Pardon?
I was saying your screen is up. Now I can see all the questions.
Can you see it now?
Yeah, I can see it now.
Right. So then IB is 10 minus 90 V1. Angle 1 minus 2 divided by 1,03. And that gives us 10 minus 90 V1 minus 9.7087 angle 2 degrees. Minus 2, né? Sorry. Yeah, right, ugly. Right. And then IB dash is I is 1 angle plus 2 divided by 1,03. That gives us 97087 minus 88 V1 minus 9.426 angle minus 90. Solving for V, we get it 1.30369.419. IA is then substituting in there 10 angle minus 90, 1,0369, angle 0.419 minus 10 minus 90. That gives us 0.075 minus J.368. IB again is 0.425 plus J.631. So now we see that SA is 0.075 plus 0.368. And SB is 0.425 minus J.631. Now this is not something that is really going to happen in practice. This is just a mathematical solution to see that you understand the principle. Any questions so far?
Sir, I got in late. Can you kindly please go back to the first part with this area? Because as long as if you can open the pages, then I'll try to see it. Then another thing, I'm failing to get that video previously, the first one that we attended. So I don't know if is there any textbook that you can recommend me to get so that I can try to practice this on my own.
Not really.
Not reason.
I've sent you most of the question papers.
Yeah, I see. Oh, this is from this question paper.
Yeah.
Okay.
All right, so there's the first one. I first did a change of 2 degrees and then a tap change of 3%. Next time, be on time, not late.
So I tried to log in on time. You didn't accept my request.
Man, bad excuse. Everybody else got in. So either you're exceptionally stupid or there's something wrong.
Come again?
I say either you're exceptionally stupid or there's something wrong.
Ah, sir.
Okay, and
Now you
then,
can
right, and then the second page is where I calculated for a tap change of 3%.
go down a bit. Go down a bit.
Right, and then the third one is the tap change and
Oh,
a
that the third one I have it. The second page, sir.
you can have it. Yes, and then you're not slow as well. All right, there's.
I have this one.
Huh?
I have this one.
So that's the second page.
This is the second page.
Yeah.
Okay.
Yes. Man, oh man. You should have gone partying with that other guy.
No, I don't go far. I don't party, sir.
All right, then there's that one with the tap change and the phase shift.
No, thank that one I have it. Okay,
Okay. Now we can try it on an alternator. We have a 10 MVA, 11 kV with ZS.1 plus 0.01 plus J.4 per unit, and E1 is 11.5 kV and delta is 4 degrees. So if we now convert that, we get 0.4 at an angle of 88.6. Current is E minus V divided by Z. That gives us 0.212 angle minus 29.1. Now S delivered or developed is E times I, the conjugate. That gives us 0.186 plus J.121. Now we're going to change the voltage to 12.6 kilovolt. Now 12.6 kilovolt is 1.1455 in per unit because E per unit is 12.6 divided by 11. That gives us 1.1455 per unit. So now, seeing that we have a resistance as well, we can't use the short formula. Now, we said P is going to remain the same, and we're just going to change E. So now we use the formula P is E over Z, E times cos beta minus V cos beta plus delta. And then you'll see that the load angle changed to 0.3518. And then we can calculate the developed Q, which is EV over Z cos delta minus V squared over Z. And there you can see it's 0.358 per unit. So you can see it changed from 0.121 to 0.358 per unit. Now we can do the same problem by saying, okay, let's make delta 2 delta 2, let's make it 6 degrees. Then, but again with the same conditions as the first one. So IA is going to be 1,0455 at an angle 6 minus 1 divided by 0.488.6. Okay, you can calculate that quickly. All right, I get it to be 0.308 minus J.341. And if you want it in rectangular or polar form, it is 0,459 angle minus 47.9. So now S is going to be E times the conjugate of I. So that's 1,0455 times 0,459 at an angle of 53.9. Because if you look at it there, delta was 6 degrees and I was 47. Right.
Mr. Leon,
Yes.
can I check with the others if IA they got the same value as yours because I get different values.
Okay.
IA.
Yeah. 0.291.
Minus 18.
Yes. I don't know what the hell it is.
Angle of 8, negative 18.
18.6. Yeah. All right, 18.6. So that gives us 24.6. Okay, 1.0455. And it is 0.291. That gives us 0.304. And then 4.6. All right, please just mute your microphone. I hear some dogs barking. Or maybe it's you. I don't know. All right, so if we change that again to rectangular form, we get 0.304 angle 24.6. That gives us 0.276. Now, if you look at the previous one, we got 0.186, and now it changed to 0.276. And Q didn't change much. It went from 0.121 to 0.126. So there you can see clearly that a change in delta and change P changes, no? And a change in E implies Q change, mostly. Okay. Any questions so far? So you got those questions that I sent you on each part of the work. Gee, people, answer me. Or have you all left?
You send it on the group, sir, because
No, we are here, sir.
Pardon?
send it on the group. Sir.
What about the group?
You send it there, the question papers.
Yes, did you get it?
No, I didn't.
Then you should pick Warren Dias and ask him to send you.
Now it's
Alright.
on the group questions. They're still there. Just check the this thing, messages.
Hey, you're not only late, you're slow as well, huh? All right, then the next chapter that we are going to do is chapter 4 and 5. All right, so we're going to do chapter 4, 4.1, 4.2, 4.3, 4.4, 4.5. This is all theory that you should know. And next week we'll do the calculations. So 4.7 you must do, 4.8 you must do. Make sure you understand it. And then 4.2 I'll start with the examples and show you. And then you carry on with 4.10, 4.11, 12, and 13. And then next week we will do the problems. And chapter 5, also all of it. These formulas and stuff looks daunting, but it isn't really. Once you've got the hang of it, you'll see that you must apply to not be able to do it. Because it's really easy. There's just a few things that you've got to know. I think I've made a summary of chapter 4 and 5. I'll look for it and then I'll send it to Warren. Warren, you must make sure these other mamparas get it as well.
I will send it.
You better. Okay. Any other questions that you may have?
Sir, can I ask you a question?
Sorry, sir.
Yeah. Once upon a time, please.
Hi, Tawang.
Ah. What's the question?
Say, it's about transmission lines.
Yeah.
Yeah, I read somewhere about the transmission. Some other guy said that in the olden days they used to generate electricity with a multiple of 11, like 11 kV, 33, 66, 132 kV. So they asked where was it that they generated the electricity in the multiples of 11? And then this other guy said that it's because of the form factor. And then the other one said that because of the drop, the voltage loss. Like if they
Yeah.
generate Yeah, if they generate 11 kV, then there will be that 1% voltage, which is 1,000 volts. And then on the transformers, on the terminal, that it will be like 10 kV. So I'm not sure if they are right or wrong.
Yeah, well, just go and read up a little bit yourself. And then next time you come and tell us.
Okay.
But in any case, they do is step up with a transformer, and you'll see that the losses are not that big. When we get there next week or the week after, you'll see.
Okay.
Okay, man.
Sir, okay, sir. I have a question also myself. Yeah? No, I just want to ask about this chapter. It's chapter 4. What's the heading for it?
Inductance.
Inductance.
Yeah, and the next one, chapter 5, is capacitance.
Inductance of
transmission line.
Of transmission lines. Okay, sir. Thank you, sir.
Everything now goes about transmission lines from here on. There's a series impedance of transmission lines. And then chapter 5 is capacitance. Capacitance of a transmission line. All right. And then I think after chapter 5, we are ready for case 1. So we'll go through a lot of these examples before then, so that you're ready. And then we will write case 1.
Another one, sir.
Yes?
I didn't get the clarity on